Hello. Right, welcome to the cognitive approach in psychology, all AO1. Okay, the main thing, the assumptions. Depending on where you are and how far you know about everything and the other approaches, this is about internal mental processes, can and should be studied scientifically. Okay, it looks at areas of human behaviour neglected by behaviourists. Processes are private and cannot be observed, so cognitive psychologists study them indirectly by making inferences about what is going on in people's minds. So we're looking cognitive. Cognitive in its word is about the brain and the processes. So the cognitive approach is obviously looking at these internal mental processes and everything about that. Okay, one way to study internal processes is through the use of theoretical models. Now, you would have already looked at models, multi-store model, working memory model. They're examples of information processing. Okay, cognitive approach also uses models. Okay, coding. Such computing models have proved useful in the development of artificial intelligence. So when you're looking at, well, that makes sense. Obviously, they can process, they can make a brain, or what they view as an artificial intelligent brain, work as a computer model. First of all, you do this, then this happens, then this happens, then this happens. Okay, and that's one of the main assumptions of the cognitive approach, that it's a lot like a computer. Okay, schema. The role of a schema. Cognitive processing can often be affected by a person's beliefs or explanations, referred to as schemas. Schemas are packages of ideas and information developed through experience. You can also have schemas that act as a mental framework for interpretation of incoming information. For example, a chair, something with 4 legs that you can sit on. Now, the way I always explain it is the idea of how schemas grow. So if you take a 2-year-old and you said a dog to a 2-year-old, his schema would light up and it might have 5, 10 things. He might say, my uncle has a dog, they bark, they poo, one's a Labrador and they're hairy. Okay, that might be all a 4 or 5-year-old could tell you about dogs. Whereas if I was to ask you about dogs, your schema, bang, all of the information that you have and your beliefs and expectations would jump up, and you'd be able to tell me probably endless things about different types of dogs, interactions with dogs, what your beliefs and expectations around are certain dogs. Might even be able to break that schema down into, Rottweiler, what does that mean to you, as opposed to what does a poodle mean to you? And these are all schemas, okay? And we use them all of the time to interpret what's happening around us. And that's the idea around the cognitive approach as well, is that we have these schemas that we rely on as mental framework. All right. As we get older, the schema gets more complicated and detailed. Hopefully I've just explained that. Adults develop mental representations for everything from the concept of psychology to a schema for what happens in a restaurant or to what a zombie looks like. Schema allows us to process lots of information quickly and acts like a shortcut to stop us being overwhelmed by environmental stimuli. Schema can distort our interpretations of sensory information, leading to perceptual errors. So what we're saying basically is that the schemas speed up what we're doing. We're using them all the time about how to open a door, what to expect, what a certain doorbell ring means, what this means, what that means. We're using them all of the time to make sure that we can process lots more information. All right, and that's hopefully makes sense. Cognitive neuroscience looks at the brain structures and mental processes, maps brain areas and their specific cognitive functions. Broca 1960 identified how damage to an area in the frontal lobe, later to be known as Broca's area, could permanently impair speech production. You might have heard of other kind of case studies of people damaging their brain, and that leads to different things happening. So the idea of the model, a computer, is the cognitive psychologists would say that this helps prove it, because if you damage a small bit of a computer, then that bit doesn't work. Your RAM doesn't work, or You know, the microphone is broken. That's that small part of the computer that is broken. The same as in the brain. If you damage the part of the frontal cortex or this, then these various different things happen. Okay. Advances in brain imaging, such as PET scans and MRIs. You may have had them. The big MRI is like a big, huge polo that you kind of slide in, and it whirs around you and can take very detailed images. Systematically observe and describe neurological mental processes. Tolving was able to show how different types of long-term memory may be located at opposite sides of the prefrontal cortex. So again, you may have seen that in shows such as House, if you haven't watched that, or any kind of medical show, when they're showing a scan of the brain and different bits light up, you know, green and red and yellow. We're able to show, you know, if you were in MRI, I'd say, right, I want you to think about when you fell off your bike when you were 5 years old, and as long as you comply and you're thinking about that, we'd be able to show, oh, look, there's that part of his brain, a long-term memory where that bit lives. Okay, so within cognitive neuroscience, we're able to prove and find so many new things about what's going on in the brain. And the idea that we can link these to OCD as well, and problems with it. You know, OCD and the cognitive approach, if and when you come to it, you might have already done it, about you know, how things are explained. The OCD within cognitive psychology would be that basically the computer's not working properly, that there's some faulty thinking, there's some faulty bits and parts of the brain going on, and that's how we explain that. Okay, next is AO3.